Hey everyone, today we'll understand how Instagram used to upload their reels from the client to the server and how did they improve their upload latency. So I'll be going through this blog step by step and you will understand everything what is in this blog. So let's get started. As you see, the topic is video upload latency improvements. So initially in 2013, Instagram introduced their video upload method. So as you can see, we have this user. He's making a reel in front of this particular phone that he will have. Then after the reel making is done, we'll have to simply upload that to the server. So initially, what Instagram was simply doing is was uploading the entire video file to the server after the client finished the uploading. Now, if we see the whole video upload pipeline, so we're simply seeing in the client side, we have this video and it is being uploaded to the server. In the server, we have these workers which actually are processing different versions of the video. We'll just see that in a minute. Then when the version are done processing, then we're making the video live, which means the video will be now available for everyone to see. Then they're actually storing the data in the data model. Now let's understand every step in a little bit more detail. Now, if we talk about this step, which is on the first step, that is processing versions. Let's say a client is provided us 1080p video. Now what we have to do is convert this into multiple versions. One could be 720, 360, 480, and maybe many more. Depending on, because why Insta is actually doing this, because different users, maybe I have a phone which doesn't support 180, 1080p, or maybe the internet connection that I had does not support that much. So they will be automatically going to maybe showing the user 380 or 480, depending on his internet speed and many more reasons. So that is actually what we do in the step of process versions. Now, if we go into the next step, which is making the video live, what does it mean? Let's see here. Now, as I already said, this making it live means that now it will be visible to all the users on the Instagram to see, right? Normally, what will happen is, let's say the user that we have, the client, it has many followers, right? It has multiple followers. Now, what Instagram will do actually, because every follower has a feed, because let's say this has a feed, this has a list of feed. What does a feed mean? Let's say when the client actually goes into the Instagram, it will see actually the videos, the reads in its feed. That's what it is. Now, when this client, what we have is uploaded a video. Now, this video is actually added into the feed of this follower. I have given you a high level idea what is actually doing it. So let's say when this user asks for the feed, it will actually get now this new video that actually this user has uploaded. So this is what it means to make the video live or publishable. Now, at the end step, we simply are storing the data of this particular video into the data model, which they're using the graph model right now. We'll be seeing that into a little bit more detail in just down below. I thought I should clear this, that we'll not be sending the full video into all the different workers. So what would probably be happening is like this. This video will be sending it to a service that will first upload it some kind of a blob storage. In this case, let's take an example of an S3. And then we'll be simply sharing the link to these workers. I think in the blog post, they've abstracted the information, but I believe there'll be a server that is between this video and these process version workers that will be actually uploading this into the S3 and sharing the link to these workers. And normally, this is how we do it. When we send a video from one service to another, we normally will be sharing the link instead of the whole video. And the data that we're storing here will not be the video data, it will be the metadata of the video. Now, I hope you understand the basic flow of their upload pipeline. Now, let's understand what upload latency is. So at the end of the day, when a client, the user that we talk about, has to upload the video to the server, it will take some time and to make it live. So let's say user uploaded the video. First, the video has to go from your mobile phone that the user that has to the server, and then they have to process it, and then at the end they will be making it live. So after every processing, let's say we have 1080 that I've given already an example, it has converted or generated all the different versions. Then after that, every version is generated, will make the video publishable or live. Then it will be actually shown or will be live and visible to everybody else. Now the thing is, user actually, if we go here, user will want the video to be live as soon as possible. So let's say I'm a user, I will want the video to be live as soon as possible, because in my mind, I don't care about your versioning, your converting the versions, because for me, I've just uploaded a video and I want it to be live. Now let's see the ways to improve that. The first step that they did was something called a publishing signal. So the idea is, instead of blocking until all the video versions are available, publish video once the highest quality is available. So now the thing is, we'll not wait for all the versioning to be done. We'll only wait for the highest version to be generated, and then we'll make the video live. So if we go actually here again, let me first delete all of this. We'll understand it again. So now at this point, what we'll be doing is we'll not wait. This will not wait for this, will not wait for this. If let's say this is the processor, the worker that is actually processing the highest version, will only wait for this to actually make the video live. Now, this versioning will not make it live. It will simply do one thing. It will actually go and store it into the database. Same, this version will also do the same. So the only thing that will be waiting to make this live is this processor, which is right now I'm saying this is highest. It could be someone else. So the processor, the worker, which is processing the highest version, the make to live server, the worker that we have here that will be making it live, will only depend on that particular worker. So if when this is done, then we'll make this live. Will not worry about all the other processes to be done, right? Now let's move now a little bit about data models, how they are storing it. What they have is they have a video asset node, like they're storing the data in the graph database. You can read it on the internet how it works, but on the high level, what we have nodes in the graph that you normally might know. So in that we have a video asset node, that is the information that we have a video information in that. Then we have a node for every single version. Now and this node is connected to these different versions of the video. And when this, let's say this is the highest version that we talked about, highest quality version, when that is done, we'll make this is publishable, which is in the asset node, equal to true. And in this case, it is saying this is not processed yet. So actually, we have not made it true yet. It's still false. That is kind of the high level architecture that they are following. So we're saying we have version nodes which are attached to the parent node. The parent node here is the video asset node. This helps us separate video and version data. So what they've done, because at this level they have created a separate, like a video information is on a video node, video that we have, and the version is on the kind of the version node. So they have segregated the data. Now you might have a question that why do that? Like if we are segregating abstraction we want, we can also do that on the relational databases. Actually, that's correct. We can have a separate table for a video asset, separate tables for kind of version nodes, instead of kind of taking them into a same table and have like one entry for every single version within video. So the actual reason why they have choose a graph database, because of the complexity of the Instagram, because like one has multiple followers and those followers has instead multiple followers, and here we are seeing might be the basic version of what they are following. So instead of going with a relational database, which is not best suited for complex many-to-many relationships, they have used the graph database. Now a higher version will send the signal to. So what happens when, let's say the worker that we have, the process worker, it is done processing highest version, it will send the information, it will send the signal to the make publish live server, then it will make it live, and it will make this here equal to true, right? So let's move on. Make mark video like publishable series, check above diagram. Okay, got it. Now video processing is resilient and flexible as if the pipeline. Yes, one more thing, because initially what we are doing is we have multiple, let's say we have 5 versions to generate. Let's go into the diagram back again. So here we have, let's go into the new diagram actually. So as you can see, what we previously have to do, because we have multiple versions, right? Or 3, 10, whatever, how many versions that we have. And we have to make it live only when every single version is correctly processed. If one of them fails, we will not be able to make the video live. Now, in the case that we have right now, if only one of them, which is the highest quality one, actually got generated, will make the video live. That is what they're saying, that it is resilient and flexible, right? And as if the pipeline fails to produce the optimal encoding for some time, we can still make video live if highest quality is available. And it is not that we're not processing other versions. It is only that we are only waiting for the highest quality version. And in the meantime, other versions actually can be generating in their own time. Now let's understand a comment that I also had a question. So there's someone who has commented it, that when we talk about actually here, that we're only waiting for the highest version. And somehow they're saying the highest version is being processed before then the lowest version. But how is that? Like, it isn't that a little counterintuitive that someone has actually questioned here? The thing is, that's what I've actually replied also, what I believe, because the video normally when we upload it, let's say I am uploading a 4K video, the highest quality then, let's say in the YouTube or Instagram, it will be the 4K. So we don't have to convert a lower quality video to higher quality. Normally we do the opposite. We have a higher quality video, we convert that into lower quality. So whatever video, the high quality the user has provided, that already will be the highest quality, and that might need only a few tweaks here and there in the video, and that's it. It will be available for the user to see. So that's what I have said. If you have any suggestions on that, you can actually set in the comment section. Now let's understand the trade-off of this approach. As we are concerned about the high quality version only in the start, what will happen if a user has a less bandwidth, he will have poor experience, right? So that is a trade-off here that we have to consider. Then we have a second approach, that is segment video upload processing. Let's see that. So what we let me actually first delete this, what we have done here. Okay, now the client will actually chunk the video after recording, and it is the client here does not means me as a user. It actually means the Instagram app that they have. It will do when, like, say the recording is done, it will divide the video into multiple parts of few seconds. Now, chunks are sent that we have here, chunks are sent in parallel to the server. Now, why would we do that? Well, we divide it and send it. Let's see. So let's say here what we have is an example. This is a video. We're breaking it into 3 chunks. Let's say it was a 6-second video. We divide it into 2-second chunks. Now we're sending it to the server. What we are doing, as we see, we have multiple here for every version. So in this, we have 3 actually servers. For the version 2 also we have 3 servers. So when we send this chunk, it will be sent to this particular version. So every chunk what we have is processed parallelly. So what we have, this first chunk, it is processed in this version. Now this second chunk, again, we'll send it to this second server. And the third chunk will be sent to the third server of this process 1 version, like worker. Now all of them will be separately processed, and the time would be divided by like the chunk. So it will be very fast. So let's say initially it was taking 6 seconds. Now it will kind of around take 2 seconds, because we have 3 workers here for every single process, right? So depending on how many chunks we have, let's say we have another chunk, then we have to have 4 servers to process every single version, right? And then again, we're still only actually waiting for the highest version to make the video live, and then we actually store that into the data model. Right. So I hope you understand this. We'll be sending video into the chunk. Okay. One more thing is the thing is that we have to, because when we chunk the video, we have to somehow understand what this chunks belong to, which video it belongs to. So we'll have a chunk ID. We'll also have a video ID. So it will actually give us the idea of this, which chunk this video belongs to, and then we have a chunk ID also to separate the chunk out. Now I hope you understand how this process actually works of chunking and sending it into the server. Now let's actually go into a little bit more detail of what it is. Now, so what they're doing is kind of transcoding, that is converting the video that they have into different versions. Now here we have, this is doing for segment 1, segment 2, segment 3. Now then they actually extract some metadata from the video. There might be some quality and everything else they have in the video, and handle some exceptions and everything. That is the second part they're doing. And then this is a very important part here, which is because at the end, when we have multiple segments, we've separated them, we have to stitch them back together. So let's say we have these 3 segments. Now we can't send this like to the user, like the segment, they will be watching first segment, second, and then the user will want the whole video. So this is the service that will actually take all the segments, and then it will be giving us its segment, second segment, third segment, and then the result of this will be the whole segment. Right, and that is the responsibility of this service, that is stitching segments. And okay, and here there are some post logic. Let's say after stitching, they have to do some business logic. They're doing it here, and then again at the end storing this into the graph database. Here we have the service has to wait till all the segments. Yeah, and the question is like the important point. Let me actually delete this first thing here. This is a very important point. Now let's see this point, that the service that we have, this here, it has to wait until all the segments are processed. Because at the end, it will send the full video only when it gets all the segments. Let's say it only gets the first 2 segments. Third segment is taking still time. So it will not actually be able to send the full video. Until it gets all the segments, it will then be able to do it. Now, so there are actually 2 things to it. One is that how would it know the segment that it got is the last segment? So there has to have some kind of a flag here in the last segment that I am the last segment, or there might be information of how many segments we have. So either they will have a key or a flag in the last segment, or they will have a number attached to maybe all the segments, that how many total segments we have. Right, and every segment will have an ID. So this will have maybe 1, this will have 2, this will have 3, so that they will know that what is the order of all the segments. Right. Now another thing, let's say it got, let's say there are total 1 to 10 segments, right? 1 to 10. It, let's say, got 1 and it got 5. Will it do anything? It can't do, because it can't merge them, right? It can't stitch them. Now let's say it got second segment. Now it can stitch this 1 and 2. So it possibly, this is not mentioned in their post, but I'm still trying to figure out how they might be optimizing things. Because let's say they might get some consecutive segments. So they will merge it. They will not wait for all the segments to get into the service. They will be starting merging if they got consecutive segments. So this is a little bit more detail how can actually they're doing this. Now let's talk about some trade-offs as we see in the previous approach. Now, as we said, like segments, if we divided them into segments, it reduces the latency because every single segment is processed parallelly. But it increases complexity because for every single segment, we have to have now its own worker, right? that is what we have. So let's say initially we have 2 workers or 3 workers. Now it will be 3 into, depending on how many segments. Let's say we have 4 segments, it will be 3 into 4, 12 workers that we need. Now every segment means separate worker, which means extra overhead. That's what I said. So because of this, we cannot have a segment length more than a particular threshold. Right, and every segment can be like few seconds. It cannot be less. Let's say we are actually doing 1 millisecond segment. So the video will be divided into hundreds of segments, and we'll be having hundreds of workers over there. And then at the end, we'll see the overhead is more than what we actually got the benefited from. So that is why we have some threshold. They have some threshold. They have not mentioned the threshold, but there will be some threshold that we will not go more than this. And they have decided it on the seconds. Let's say we have a 10-second video, we'll be dividing into a segment of 2 and 2. Right? There'll be now 5 segments in total. Yeah, that's what I've said here. 2 small segments means wasting resources to a tiny work we're doing, right? Now let's move on. Extra steps. Okay. Now one more. Now we have a totally extra step here, that is stitching, which we do not have initially. That we have to take the segments, stitch them up together. That requires extra resource. And here the stitch service will require quite a bit of IO. The reason is because if they have to stitch multiple segments, they have to first download them in the service and then stitch them together. While stitching, all the segments needed to be available locally. The segments that we have, they need to be available locally in the stitch worker. So downloading segments needs input output. So they will be downloading and storing into the local disk, the memory, not the memory, hard disk, and then that needs the IO. Right. So that is an extra overhead. So that's why we want to threshold the size of the segment. So only videos greater than threshold length are segmented. That's what we discussed. In short video, it is more overhead than benefits. Already discussed about that. Now let's see the last approach that they were following to get more benefits out of it. Let me actually first do this. Yeah. What do we have? Now, the thing is, sometimes the media uploaded, the video that is uploaded by the client, it's already ready for the playback. That is already ready to play by the users, right, on the most devices. It means the format that the user has uploaded, it actually is quite widely used. Maybe they're using MP4 and some others, so which actually are widely used. So in our case, what we'll do, we'll skip the video processing. So let's see in this, what we have is a video. Again, we're segmenting it, sending it to the server. What we are doing, we're parallelly doing the process versioning and pass-through check, right? So what will happen, this pass-through check actually takes much lesser time than the processing version. So actually, if the video is able to pass through, they will make it live and they will not even have to wait for the highest version, right? And we'll make it live and store it into the DB. Now here we have, it reduces the latency. We won't have to wait for the transport the videos. They will be transporting the videos, but we don't have to wait for it, right? Same like when we're not waiting for other versions, we're only doing the highest quality version at that time. Now we are only waiting initially for this. Let's say the pass-through check what we have, it fails. It said, okay, now this is not, the video uploaded is not actually eligible. So we'll again have to wait for the highest quality then, right? Now let's understand in a little bit more detail what this pass-through check is doing. So we have this eligibility, this pass-through check here, what this service is doing. So it is doing multiple things, but on the top level, they have said it's checking codec and bitrate, right? A codec is actually the way that we compress and decompress a particular video. The example is H.264. So we use it to compress actually the video to send it over the network. Right. So what is happening actually, let me give an example how this kind of works, the compressing. Let's say we have a scene going on. Let's say it's me, the webcam. What will happen in the webcam, the overall surrounding that we have in the left and right, it is not going to change. So let's say for a couple of minutes, it is the same. So it will kind of remember the first frame and which all we have all the information, then only remember the changes in the frame. Let's say because I'm moving the hand, it will actually remember the pixels that changes because of me moving the hand, and the surrounding will always remain the same. So it is actually reducing quite a bit of size using these kind of codecs, right? And while playing the video in the video player, and now the video player will know that the video, because we have an information that it's using H.264, so it will know how to kind of decompress it and play this in the player. Right, so that is a little bit about the compressor and decompressor. I already said how it actually a little bit works. Then we have this bitrate. Bitrate is kind of related to the quality, and more bitrate means large size. Someone who have a more idea of how bitrate works and the videos, they might be able to explain it much better. But I've just simply given you a high-level idea. So the problem with this is if we have a larger bitrate, so loading will take longer time for the user with the low internet, right? So I was saying, so we have to check codec should have widely supported codec and the limit on the bitrate. That's what we said. Now here they have also a little bit mentioned there. It is not just eligibility check. They're doing few more things, checking about the MP4, the extension that they have, and maybe repairing the video if it is maybe corrupted or something. Then they do something called a transmux, and then they put into the data model. Now, what this transmux is, it actually on the high level, again, we have this MP4, this extension that we have, it's also called a container, MP4. Now, what it is, it's actually in a container, we'll have kind of two things. One is in audio. So what we have, audio and a video. Right. Now, what they're doing in the transmux is not changing the audio and the video. They only change the container on top of it. Now, MP4, they'll be changing into MKV or something like this. So that is what they will do on this level, transmux level. And when this everything is done, we make the video live. That's what we have, right? That's what we have. The containers, MP4, MOV, extra, they are containers. And here we said it greatly improves the latency. As we said, it is actually much faster than the transcoding. Transcoding is converting the video into different versions, right? Now, this is something what is next. They have mentioned what they are planning next. So what they have mentioned here is we don't need to store all the video versions for old videos. Old videos means, let's say, a video that is not being used, that's not being played much. So they don't need to store it. And if the video actually got certainly more views, they will try to regenerate the versions. So they will be saving a lot of space instead of storing all the versions of this old video, which will probably never be used. And then thanks for watching the video. If you like it, share, subscribe, yeah, whatever normal needs to be done.